All right. What's going on, everybody? All right. I think give it a minute or two here. This is going to be part 4. I think it's actually, we should be able to finish up the end of this this workshop here. Still getting used to StreamYard here. Trying to figure out, I added these little social media tags at the bottom here. Kind of made a little background thing today, so I think it looks a little bit better. Could not figure out how to add like background music, so there's music playing, but I had no idea if it's coming through the stream or not. So all right. So yeah, I mean, I guess let's go ahead and get started. So yeah, I mean, this is part 4. In the previous parts, we've been able to go through all these different modules here to, learn the fundamentals of Python using AWS or on AWS, which was really cool because we got to work with like Amazon Translate, and working with data with using Python, which was really cool. And so go back and take a look at those other 3 parts. We go through all these other modules here, but today we're going to be doing persisting data. And then it looks like there's another section down here for building in AWS, cleanup, and congratulations. So not too much left here to do. I think I like having like the full side-by-side screen with like the workshop. But if there is like a point in which I think is good to add notes, I still have these down here. So we'll just add some notes for persisting data. Today persisting, and this is using Notion, so I'll actually be able to add. That's what I was looking for. I'll actually be able to add or share these notes later, within the description of the videos or whatever. Yeah. So with that, I mean, before I forget, let me just add my cool banner here. So this section is persisting data. I went with this like minimal. Let me see what I think I like it better when it's like that. Yeah, that looks cooler. Oh, my display name's not coming up either. Interesting. Anyways, so persisting data, right? So often in AWS, we need to store data in persistent storage. Persistent storage will retain the data once the server is shut down or has been turned off. A few different types of persistent storage are listed below: S3, object storage; EBS, high performance block storage; RDS, a relational database; DynamoDB, a fully managed key value document database, often referred to as a NoSQL, right? Document DB with MongoDB compatibility. Again, another document type database. Redshift, data warehousing. So in this section, we're going to look at DynamoDB, which is awesome. All right, DynamoDB is a key value and document database that delivers single-digit millisecond performance at any scale. It's a fully managed, multi-region, multi-master, durable database with built-in security, backup and restore, and in-memory caching for internet scale applications. DynamoDB can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. That is crazy. Yeah, I think like Amazon.com uses DynamoDB, and that's how they handle the data for when they have Amazon Prime days, and they just get smashed with tons of, well, obviously like 10 million or 10 trillion with a T requests per day, right? That's incredible. Databases are definitely like not one of my strong suits. And in fact, I want to learn more about like databases and like, uh, database administration. Um, Definitely think I can grow a little bit there. In fact, after we finish up this particular workshop, might look down here at the different database workshops to see if there's something that perhaps we can go through in that section too. So I can zoom in there a little bit. It looks a little bit better. But yeah, maybe we go through the DynamoDB labs or something like that. So, but for now, it looks like we're going to get sort of a sneak peek in how we can use Python and DynamoDB. So, looks like this is taken from the another tutorial. Oh, within the docs. Okay, cool. So in this lab, we'll use DynamoDB rather than a local version. You're going to use the Python SDK Boto3, which we've been using with Amazon Translate, to write some simple programs to perform the following Amazon DynamoDB operations. Create a table called movies, load some data in JSON format, perform create, read, update, and delete operations on the table, run some simple queries. Sounds cool. Let's go. All right. So in this step, you create a table named movies. The primary key of the table is comprised of the following attributes. Year is the partition key. The attribute type is N for number. Title is the sort key. The attribute type is S for string. So if we copy the following program and paste it into a file named movies create table.py, change the region to US West 2. Okay. All right. So we need to import Boto3 Dynamo DB equals Boto3 dot. So we're using it at the resource level. So now we create a variable called table, and then we say call DynamoDB, and let's see. I don't really get like. I'm just curious to see if we get like code completion or anything like that. So apparently not. So create table, and if we just do something like that and say, now we just fill in the parameters for this. So table name equals movies. Key schema is a list with JSON objects. So that's the partition key. Okay, and then we create the, I'm just gonna go ahead and copy this in. So we create the sort key after that. And then after that list for the key schema, we add the attribute definitions equals another list JSON. I'm gonna lower this down a little bit. So again, the attribute name So we're making the type of n, which is a number. Then if I'm just gonna again copy and paste the second part here. Okay, and then we like provision some resources to it, right? So provisioned throughput equals. Cool. And then finally, looks like we can print the status. So in the create table call, you specify the table name, primary key, attributes, and its data types. Okay, so this provision throughput parameter is required. And now if we run our program here, Python movie, I just named it movies.py. Oops, there's a typo. I can't believe I've gone this far without not having a ton of typos. Usually pretty terrible at typing. So let's try to run that again. Wow, I'm really off today. So that is wrong. Let's try that. Third time's a charm. All right, let's see what it says. Okay, so an error occurred when calling the create table operation. Table already exists. That's weird. Let me just go over to. Have I done this before? I don't think so, but I do mess around quite a bit. Looks like. So I wonder if it created. Interesting. I mean, that's today. So it still created the table even though we got those other errors. Let me just go ahead and I'm actually just going to delete this and then let's try to rerun it. All right, let's go back in here. Now without the typos, let's see if we can run that. So it looks like it worked that time. So it's creating. If I come back over here and refresh. Okay, so now we got movies. Cool. Curious what this is. Okay, so more documentation there around working with tables and data. All right, step 2, load sample data. Let's see. In this step, you will populate the movies table with sample data. This scenario uses a sample data file that contains information about a few thousand movies from IMDb. The movie data is in JSON format, so as shown in the example. For each movie, there is a year, a title, and a JSON map named info. So this is kind of what it looks like, I guess. In the JSON data, note the following. the year and title are used as the primary key attribute values for the movies table. The rest of the info values are stored in a single attribute called info. Okay. I've never seen this movie before. Turn it down or else? Curious, like, turn it down or else. Oh, or no, that's a music video. Huh. Interesting. Okay. Well, guess it's like a comedy and drama, but it got 6.2. That's not terrible. Interesting. Okay. All right. So download the sample data. We can just run this wget command from the CLI or from the terminal. And now we have, what did it save it as there? Oh, here's our movie data.zip file. Okay. So unzip movie data. Load the sample data into the movies table. So it looks like we need a new file here. So again, we'll bring in Bodo 3, not 2. Import JSON. Import decimal. So Dynamo equals Bodo 3. Yeah, one thing that trips me up too. So like here we're interacting with at the resource level with DynamoDB, but if you remember with Amazon Translate, it was the client. So it was like Bodo3 dot client and then translate. So I need to probably learn more about why that is. US West 2. Let's see, we're using JSON load instead of loads. So now it looks like we're just kind of like parsing the JSON to get the year, the title, movie equals title. Yeah, notice here too. We're converting the year, which is a string in JSON, right? But we're converting it to an integer. It's all coming together. So info is like the rest of the like metadata of the and info. And then we can print while it's adding the data. Within the for loop, we're at like printing this each time it adds a movie to the database. So adding movie. Oops. And then finally, we put that movie into the database. And here I think we're just specifying like, or mapping, the values that we get from looping through the data and then mapping those to the partition key and the secondary key, I think it is. All right. So now this should put that data from it should put that data from our movie data JSON. Oh boy, looks like there's a lot. Yeah, it should put all of this into our empty movies DynamoDB table, right? It's called the sort key. Okay. So, anyways, all right. Let's run that and let's see if we get some data into our DynamoDB table. So, movies underscore load.py. All right, let's run it. Damn it. I knew it. It's too good to be true. Full of typos today. All right, let's see here. So, forgot a comma. Classic. Did I misspell that? Is it? That's movie data, not movies data. Boy, glad this is part 4, right? Like, this is getting pretty bad. All right, let's try it again. Clear. Cool. Now we can see it's looping through all of that that big old JSON file, and adding each item, which includes the year, title, and info, into DynamoDB. Some of these look familiar. I mean, I can't imagine like trying to add all of this, one by one. This is really nice to. It's a good way of showing you, how, just how many lines is this? 24 lines of code that we're able to like iterate through a massive JSON document or JSON file, and be able to programmatically add data to a NoSQL database. It's pretty cool. It might not ever end though, so let's just look to see. So it's filling up now. Wish there's a way to see like how many. I'm just gonna push this over a little bit more. I wish you could see like how many items are in the database here. I wonder if there's a way to do that. Like, how do we figure out? Maybe that's in the next. Okay, yeah, I'm getting a little ahead of myself. Maybe so. Okay. Whoops. All right, it looks like it finally finished. So, step 3: create, read, update, and delete an item. So in this step, you'll add a new item to the table. All right, looks like we need a new file here. helper class to convert a DynamoDB item to JSON. Okay, so decimal encoder. That's in JSON encoder. Okay. And then we have a function called default self code. So if is instance O decimal dot decimal FAS O 0 return a float. Okay. Just gonna copy and paste that in there. The Big New Movie, which was made in 2015. If anybody's seen it, let me know. All right, so then now we create response and we put the Big New Movie into the table. Say year, title, info. I guess, yeah, I guess I don't need anybody to tell me that they've seen it before because apparently nothing happens at all. Sounds like a thrilling movie. Okay, so rating. Okay, this is where we use that helper class. I'm guessing. So decimal dot decimal. Seems like a lot just to that, but anyways. So now we can say, here's our print debugging, right? Again, just making sure that it works. indent to make it look all pretty. And then CLS equals decimal encoder. All right. So the primary key is required. This code adds an item that has primary key, year, title, and info attributes. The info attribute stores sample JSON that provides more information about the movie. The decimal encoder class is used to print out numbers stored using the decimal class. Interesting. Okay, so the Boto SDK uses the decimal class to hold Amazon DynamoDB number values. I did not know that. Sounds like something worth making a note about. Just gonna paste that in here. All right, so if we run this now, Python movies new. Looks like it works. Yeah, okay, so in the next little section here, we can read an item. So I'm assuming, yeah, we'll try and read what we just put into the table. You can use the get item method to read the item from the movies table. You must specify the primary key values so that you can read any item from movies if you know its year and title. So I'm just gonna let's make a new file here and call it movies underscore read. I'm just gonna paste in what we did in this one in the movies underscore new, because now all we do is add. We have some additional import statements here. Keep the helper class. Bring in DynamoDB. The table is called movies. The title is called The Big New Movie, made in 2015. And then now, instead of this put method, we want to read. So in this try except block response. Yeah, and sorry, like you gotta watch me type through this, but I just find it's helps me learn better when I'm actually typing instead of just like a copy and paste. It's I feel like I absorb it a little bit better, even though I'm basically just copying it from the other screen here, or the other you know. So response item and print it item succeed. And then we do another JSON dumps, which I should have probably just left. Oh, it's right here. All right. So let's try that. So this will be feed. Nice. So we were able to get that item. It got a 0 rating. The plot is nothing happens at all. So I think I'm gonna try. Let's just try another movie really quick. First, I need to figure out one of my favorite movies is Superbad. So it came out in 2007. So let's see if we can find Superbad in that. Let's see if it comes up with the plot and whatnot. So nice. Yeah. So we were able to find another movie in that list, or in that JSON file. So it shows the actors. Let's see. The plot is two codependent high school seniors are forced to deal with separation anxiety after their plan to stage a booze-soaked party goes awry. Now I gotta go watch it. Oh, it only got a 7.6 rating. I thought it was better than that. So Superbad is a classic for sure. All right, let's go back over here. What's the next step? So update an item. You can use the update item method to modify an existing item. Um, let's see. You can update values of existing attributes, add new attributes, or remove attributes. Okay, so it looks like we're gonna update the big new movie. So again, let me just copy this. Oops. I'm just gonna paste that in there. So we say update item, the key, or passing in the title and the year. And then update expression. All right, so if we run that, I didn't save it. Cool. So if I come back over here and say the big new movie came out in 2015, and if we run Python movies underscore read again, yeah, now that data is showing up. Very cool. Okay, yeah, this update expression kind of interesting. So this program uses the update expression to describe all updates you want to perform on a specified item. The return values parameter instructs DynamoDB to return only the updated attributes. Okay. All right. Increment and atomic counter. DynamoDB supports atomic counters, which use the update item method to increment or decrement. Is it decrement? Decrement? I don't know. Lower, I guess, the value of the existing attribute without interfering with other write requests. All write requests are applied in the order in which they're received. The following program shows how to increment the rating of a movie. Each time you run the program, it increments this attribute by 1. So I'm just going to copy and paste this one in. Oops. Update. let's see this in action. Maybe it'll make more sense. I guess, yeah, it's just adding. Hmm. So right now it's at a 5.5. So this should actually bump it up to a 6.5, right? I mean, that would be +1. So yeah, that should be right. Oh, let me save this. Update 2. Okay, cool. So then if we do another read, yeah, now we get 6.5. It's kind of cool. I should go back and make super bad a little bit higher. Okay, so update an item conditionally. The following program shows how to use update item with a condition. If the condition evaluates to true, the update succeeds. Otherwise, the update is not performed. The item is updated only if there are more than 3 actors. So the Big New Movie had 3 actors. So here we got the try accept again. So it's going to try to update the table if this expression evaluates to true. So we're able to these expressions don't make a ton of sense to me. Like I don't know how they came to this. Like remove info dot actors. Okay, I'm assuming I can look through the docs and stuff, but okay, so we're just gonna do another copy paste here. Condition request failed. Okay, so let me just add that here. So if we run that, we get the output that the condition failed. I'm gonna move this over. Okay, so let's see. So it gets to here where it's attempting conditional update, and then it tries to update the table with the item, but the conditional request failed we get this this client error, right? And so the program fails because the movie has 3 actors in it, but the condition is checking for greater than 3 actors. The program, okay, so we need to modify the condition expression to make it greater than or equal to 3, which is here. So if we run that again, it works. Wait, so does that? Did I? Oh, so okay, so it removed an actor there. Weird. Okay. Because now if we run it again, it should fail, right? Yeah, because there's only 2 actors. So, all right. So this update expression actually removes one of the actors. Learning something new today. Delete an item. You can use the delete item method to delete one item by specifying its primary key. Optionally, you can provide a condition expression. So let's try to copy this over here and then look through it. So movies, delete. All right, so what's it doing? So we still have this helper class, still bringing in Dynamo. All right, so we have another try except block here. Except this time we're using the delete item method. Okay, so if the condition expression equals the rating is less than or equal to the value, so the right now the big new movie is rated 6.5. So I believe this would fail, right? Because it's not, the rating right now is not less than or equal to 5. All right, let's try it. Right, kind of what I thought. The program fails because the rating for this particular movie is greater than 5. Modify the program to remove the condition think that was right, actually, because we still need to. I'm not really sure what they're going at here. Like, modify the program to remove the condition in table.delete item. I mean, so it's at 6.5. So if we said, or I can even just make this 6.5 because this movie is rated at 6.5, which is less than or equal to it. So I don't know. Let's give this a shot. Okay. Or 7. Yeah, I'm not really sure what it's trying to get at here, but okay, we can move on. Kind of. All right, step 4. I think this is. Oh, there's an optional spot here. So step 4, query and scan the data. You can use the query method to retrieve data from a table. You must specify a partition key value. The sort key is optional. The partition key is for the movies table is composed of the following year, which is the partition key, and has attribute type of a number. The title is the sort key and attribute type of a string. To find all movies released during a year, you need to specify only the year. You can also provide the title to retrieve a subset of movies based on some condition on the sort key. For example, you can find movies released in 2014 with the title starting with the letter A. In addition to the query method, you can also use the scan method to retrieve all of the table data. Yeah, so I kind of remember this from like certification training. Query is a more efficient way to like search through the database, whereas scan is obviously like more intensive because you're retrieving all the table data. Yeah. So it links us to some documentation here that probably gives more details on the difference between querying and scanning. So query all movies released in a year. The program included in this step retrieves all movies released in the year 1985. Yeah, so here's that query method, and then again another like key condition expression where it's using the primary key, which is year, and then setting that equal to 1985. So once it stores that into this response variable, then you can iterate through that response with a for loop to print out the year and title of each movie in 1985. So I'm gonna make another movies for query. Probably going to be a lot. Oh, not too bad. Uh, Nightmare on Elm Street. I think I've seen that one. Oh, Back to the Future, of course. Rambo. Nice. Rambo and Rocky. Man, Sylvester Stallone was on fire that year, I guess. Right? He played Rambo. I know he's Rocky for sure, but pretty sure. The Breakfast Club, Goonies, legendary. Um, let's see. Let's see if Superbad comes up in 2007. There it is. And there's some good movies in 2007. A lot of movies, actually. Wow. Cool. All right. So the Bodo 3 SDK constructs a condition expression for you when you use the key and attribute functions imported from Bodo 3. Okay. So that's okay. That's where we're getting the ability to do this. Uh, for a list of available conditions, this looks like something useful to. Been pretty bad at keeping notes, but the preceding program shows how to query a table by its primary key attributes. In DynamoDB, you can optionally create one or more secondary indexes on a table and query those indexes in the same way you would query a table. Secondary indexes give your applications additional flexibility for allowing queries on non-key attributes. All movies released in a year with certain titles. The program included in this step retrieves all movies released in a year in 1992 with the title beginning with the letter A through the letter L. It's kind of cool. So you can get pretty creative in, how you're sort of like searching through your data. So let me just save that and let's run Python movies query 2. A few good men. A league of their own. Very cool. All right. The scan method reads every item in the entire table and returns all data in the table. You can provide an optional filter expression so that only the items matching your criteria are returned. However, the filter is applied only after the entire table has been scanned. The following program scans the entire movies table, which contains approximately 5,000 items. The scan specifies the optional filter to retrieve only movies from the 1950s, which is approximately 100 items, and discard all others. So it looks like here we're just specifying the year. Got this like between method, which is cool. 50 and 59. And then now, yeah, we're using scan, filling in the parameters with these values here. Okay. So let's go ahead and run that, see what happens. I need to save it first. So Python movies scan. Very cool. Let's see. Yeah, I'm not familiar with a ton of movies from the 50s. So let's say 1990 and 1999. Oh, Tommy Boy. It's really cool though. Can be very useful to get some data out of Dynamo. Projection expression specifies the attributes you want in the scan results. Filter expression specifies a condition that returns only items that satisfy the condition. Well, this is kind of interesting. So, provides the name substitution. We use this because year is a reserved word in DynamoDB. You can't use it directly in any expression, including key condition expression. You can use the expression attribute name hashtag YR to address this. Oh. Cool. You can also use a scan operation with secondary indexes that you create. Looks like there's like a link to the docs for that as well. All right, yeah, I guess last step here is to delete so we can write another Python script to actually delete the database or the table. I already have them. That's weird. Oh, because we were deleting items, but I'll just save it as movies. Delete table. .py. Run that. Yeah, you can see it. It's, our movies table is gone. Cool. All right. So that was persisting data. I think that might be the end of the workshop because building in AWS, it says here, learn best way to learn Python or any language is to build something. Definitely agree with that. Let's see. So I guess it's linking us to other workshops, which, again, like my next step here is to go through here, maybe do some Kubernetes or something like that. I'm not too sure exactly what the next workshop will be. Maybe I'll do one of these where, building Lambda functions with Python, sort of like build on what we've learned through this workshop to continue to like build out Lambda functions, which are super useful. Or yeah, the CDK. I freaking love the CDK. So that, you know what? That's probably the next one. I think the CDK workshop is next. Although I don't know if like oh yeah, they have a Python one. Duh. Yeah. So yeah. Oh yeah, this Python workshop. Well, I guess this will be the next thing we learn on, or next workshop that we go through, probably next week. So let's see what else. Delete your Cloud9. Yep. I might actually create a repository on GitHub and post some of these scripts that I've learned with the notes, the streaming notes that I've taken, so that I can kind of refer to them later and not just kill this Cloud9 instance without really remembering anything else. So yeah, that is it. And congrats. I think, wait, let me see what did this say. Congratulations, you've finished the Learn Python on AWS workshop and learned a lot. Awesome. All right. Thanks everybody for watching. See you next time.